There are a number of challenges when designing a new system. Memory is one of them, and compression is an interesting technique that can improve both performance and capacity. So can you tell us a little bit about your company and where you're taking this?
Absolutely, Bill. I'd like to give you some background about the company. So, ZeroPoint Technologies was founded back in 2016 and is based out of Sweden. So, it was founded by Per Stenström and Angelo Saralakis. They've been researching compression algorithms for many years. And then what they've come up with is a technique to compress and compact and then transparently manage memory and do it in a lossless fashion and apply it in such a way that it operates in the nanosecond domain. That's why it can be applied to the memory technologies.
Now, you have a number of different levels that you can address, everything from caching to storage. How does that work? And in particular, especially on caches, you're talking about typically 64 bytes worth of information.
That's correct. So let me explain a bit about the algorithm. So the way the technology works is what we figured out is the algorithms in the market out there today, they're made for storage. They work in the microsecond because you need to operate at a page level or block level granularity, which is wonderful for storage. You can afford to work in microseconds. When you're talking about SRAM compression, especially say last level cache type SRAM, at that point you can't afford to wait for pages and blocks. So that's why the algorithm that ZeroPoint has developed actually operates at a 64 byte granularity. And that's where we're able to compress at a 2 to 4x compression ratio and do it in a few nanoseconds. That's why it's practical to be used for SRAM applications.
One of the challenges is if you just compress something and just store that, you don't necessarily get the total efficiency. How do you actually pack this data in? Is that part of the application?
Great question. So you're absolutely right. So if you simply compress the data, but then you don't compact it, so that will not give you the benefits you're looking for. So that's why what ZeroPoint is able to do is compress the data, compact it, and then transparently manage it. Whenever the data changes, that's something our IP is able to manage. So like I was mentioning before, ZeroPoint Technologies is an IP licensing company. So we provide this hardware accelerated compression, decompression IP block, which can be integrated into any SoC or processor. And then we take care of compression, compaction, and transparent memory management, which makes it possible to do this operation in nanoseconds.
What kind of application spaces are you targeting with this kind of technology?
Well, that's a great question. So in terms of the market segments that we see this technology resonating, there's two major markets. One is the server market, and then the other is the smart device market. So here's the challenge in the server market. So we've all heard about the infamous memory wall everyone talks about. Well, that wall is for real. And we are seeing it as SRAM has stopped scaling now, going down below the 5 nanometer node. So you're running into challenges how much cache you can put onto a chip. And then on the other side is memory. There's DRAM and how many slots you can put. So the industry has moved to CXL. So there's many wonderful innovations coming up. But in spite of that, it's not enough. So with this, what we are finding is, for example, I'll take CXL as an example. Recently, the hyperscalers put out a spec on the Open Compute Project, OCP spec, for hyperscale CXL tiered memory expander spec. And out there, they have made compression a must-have. And they stated three major reasons. One is sustainably expanding memory for AI applications where there's an explosion of these memory models which require extensive amounts of memory. And then the second thing is also for efficiency reasons. And of course, cost. When you talk about the dollars per effective gigabyte, if we compress it by a ratio of 2 to 4x, that's allowing you to pack much more in much less. So that's the segment we are seeing traction. We're seeing customers coming out with requirements on SRAM compression because what they're saying is there's only so much space available. And we're at the Chiplet Summit, so we're seeing chiplets have come into play because of these challenges where digital logic scales differently than memory. And so now customers are looking at, oh, now I need to have disaggregated architecture. So these are some major pain points. On the other side of the market is the smart device market, where there are two main challenges. One is these are really small form factors we are talking about. Think smart watches or phones and other such devices. So you only have a certain amount of battery you can pack in, and then there's only a certain amount of storage you can pack in. So if what we do in these smart devices, we compress the memory, because memory is precious in these small devices, and we're able to then offer the 2 to 4x compression ratio, so you can pack in more. But more importantly, we do it in a hardware accelerated fashion, which means that compressed data can be loaded up much faster in nanoseconds, and then that's what actually is visible to the user as a user experience, versus doing this compression in software and then you're waiting for your apps to spin up, which is not acceptable for a user experience. I just want to wrap up by maybe the three key takeaways with this compression technology, which is the three major benefits. One is 2 to 4x compression ratios for both SRAM compression and main memory compression. There's a total cost of ownership reduction by about 20 to 25%, because there's less traffic now and power moving out on the DRAM bus. There's a higher hit ratio on the SRAM side, so the processor can be occupied that much more. And then finally, we do this 1,000x faster than software compression technologies which exist out there today. I think those are some of the key benefits. That's why we really enjoy working with customers to help solve this memory vault problem.
Very good. Thank you.
Thanks for having me, Bill.